Hey everyone, Mr. Newman here, and we're going to learn how to model with functions. So we've touched a little bit on functions in class, but let's go ahead and figure out how do we use these in situations. So, first thing we need to talk about are independent and dependent variables. In the winter, more electricity is used when the outside temperature goes down and less is used when the outside temperature rises. So, what's going on here? Well, we have the two variables, the things that are changing are electricity used and the temperature. So first thing you always want to do is identify your two variables. We got those two variables, okay? That's what's changing. Then we need to fill out the sentence. The blank depends on the blank. One of those variables depends on the other variable. So which is it? Well, the electricity used depends on the temperature. If the temperature changes, then because of that, the electricity changes. So that's how I can say the sentence, the electricity used depends on the temperature and not the other way around. That means that the independent variable is temperature because it does not depend on any variable here. And the dependent variable is the electricity because it depends on temperature. It depends on another variable. Go ahead and write that down, that the independent variable, kind of like independent children, they don't depend on anyone. They're independent. And dependent means it depends on another variable. So you always want to identify the independent and dependent variable because the independent variable is always the input, or x, and the dependent variable is always the output, or y, and we'll write that down in just a moment. Let's look at this other situation here. Here we have two variables. That's, rewind. Let me read it. Amanda babysits and charges $5 per hour. The two variables we have are money and time. And the time is measured in hours here. The money is the thing that depends on the time because however much money Amanda gets, that depends on how long she babysits. She babysits for longer, that means she's going to make more money. She babysits for less time, she's going to make less money. So the money depends on the time. Well, that means the independent variable is time and the dependent variable is money. Just a heads up, if time is one of your variables, it is almost always the independent variable because time does not depend on much. Time just keeps going regardless of what's around it. So if you have time as one of the variables, it's pretty safe to say it's an independent variable. All right, so I just said before, in functions, the input is always the independent variable, and the output is always the dependent variable. That means whenever you can identify the independent and dependent variable, you can start thinking about your function in terms of input and output based on which one is which. So in this situation, I want to start thinking about the money and time as money is my y because that's the dependent and time is my x because that's the independent variable. So in this situation, let's fill out this table based on Amanda's babysitting rate. So the input is the independent variable. In this case, that's time. It's always a good idea to put the units in parentheses afterwards. That way you don't have to write 1 hour, 2 hours, 3 hours, 4 hours. And then the output is the dependent variable, and that's in money, which money is a unit in of itself. Now, if she babysits for 1 hour and she gets $5 per hour, that means she makes $5. If she babysits for 2 hours, she gets $10. 3 hours, $15, and 4 hours, $20. So our function we can write is using our function notation like this. Do you remember f of x? That's saying the input is x, and the output is whatever is to the right of this equal sign. Well, the output is always 5 times the number of hours. So we're going to write that as 5x. When you plug in 1 hour into this function, when you plug in 1 right here, you're going to get 5 times 1 on the right. And that would give us this value right here. If you plug in 2 right here, then you'll get 5 times 2, which gives us 10, which is right here. So you see how our table and our function matches up here. Another way to write that is y equals 5x. Those are interchangeable. The only downside to this is you can't see the input happening on the left, but that's okay. This is what you guys have used before for graphing, and so that's helpful to know that. Just as a reminder, the dependent variable, that's the y. That's also the right side of the equation, the whole right side, the output, okay? While the independent variable is the input. You can see it there on the left side, or you can see it on the right side there and there. So the dependent variable is the output, the independent variable is the input. Now, let's use this equation to calculate how much money Amanda would make in 10 hours. Well, the way you need to write that is f of 10, because hours, time, that's our x variable. So 10 is x in this situation. So I'm going to write rewrite my function first of all, f of x equals 5x. And then I'm going to write down f of 10, because 10 is the input, and that equals 5 times whatever I just plugged in. So everywhere you see an x, I should replace it with my input, because I just replaced it right here. So 5 times 10. And when you calculate that, 5 times 10 is 50. So that's how much money Amanda makes in 10 hours. Amanda would make $50. Now, what does f of 6 mean in this situation? Well, we know the input is 6, because the 6 is sitting right there inside the parentheses where the input sits. Remember, the input is the independent variable, and in this case, that's time. So that means f of 6 means how much Amanda would make in 6 hours. It doesn't just mean 6 hours, because it's f of 6. Remember, the f of means we're talking about the output of the function. So f of 6 is the output. 6 is the input. So f of 6 means how much Amanda would make in 6 hours. All right, let's create some functions from situations and practice that a little bit. And we're also going to solve some equations using that. So right here, a lawyer's fee is $180 per hour for his services. Yes, that is true. Lawyers charge a whole lot of money for their time. The question is, how much does the lawyer charge for 5 hours? Remember, when there's a question, we can use this to guide our variables. Oftentimes, what you're asking for is the independent or dependent variable. Now, money and time are the two things. Remember what I said before, is that time is almost always an independent variable. So let's go ahead and write that down there. If you think about it, the money depends on how much time the lawyer spends. So that means that the dependent variable is money and the independent variable is time. Our equation always starts off with f of x equals, and what we need to think about is, all right, what is happening to the time to figure out how much money the lawyer charges? Well, if it's $180 per hour, that means it's $180 times the number of hours. So I'm going to go ahead and write 180 and recognize that because time is the independent variable, that's going to be equal to x. So 180 times the amount of time is 180x. Great. Well, let's just solve this equation using the formula. F of, let's see here, that it says how much does the lawyer charge for 5 hours? That means f of 5 is equal to 180 times x, but instead of x, I need to replace it with whatever we just plugged in. That was 5. So 180 times 5 is 900. There's the answer to our question. The lawyer charges $900 for 5 hours. Wow, that's a lot. All right, so this next one, I'll get it started for you, and I want you to finish it. The admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go to the carnival and then go on 12 rides? Notice I'm already using the question to help me identify the variables. How much does it cost? That means money is one of the variables, and go on 12 rides is the other. So we don't have time, but we do know that how much it costs depends on how many rides you go. If you go on more rides, it costs more. If you go on fewer rides, it costs less. So because how much it costs depends on the number of rides are the independent variable, and the dependent variable are the cost. All right, let's start writing our equation. So f of x equals, it's always good to identify what is the x in this situation. Here it's the independent variable, so that is, the independent variable is the number of rides. I do want to write one thing on the side first, though. Notice the admission fee at the carnival is $9. That means when you go to the carnival, you have to pay $9 to get in. Well, it's not dependent on how many rides you ride, so that's just going to be a flat rate, $9. So we're not going to multiply that by x. So I'm just going to put 9, and I'm going to add that to how much each individual ride costs. So let's see, each ride costs $1.75, so all the rides together are going to be $1.75 times x, where x is the number of rides. Notice the 9 is not multiplied by the number of rides because you always pay $9 regardless of how many rides you go on. So I want you to finish answering this on your own. Make sure you write f of 12 because 12 is the input for the question, and fill out the equation and go ahead and solve it. All right. Last thing we need to do is talk a little bit about domain and range from these situations and these functions. So Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function for the total amount collected from ticket sales and find a reasonable domain and range. Well, first thing I want to do is find the independent and dependent variable if I'm going to write a function. We have the total amount collected, and we have ticket sales. Total amount, that's total amount of money. So which depends on which? Well, if you sell more tickets, then the total amount of money collected changes. So that means ticket sales must be the independent variable. And the thing that depends on the ticket sales is how much money was collected. Let's start writing our equation with f of x equals. I want the x variable to be the independent variable because it's number of tickets. And it's $2.50 per ticket. So I can say 250 times x. But he already has $20 worth of tickets. He's already sold that much. So he's already collected $20, so we need to add $20 to the very end of that function, or the end of that equation. So there is our function. Let's think about the domain and range. One way to check domain and range is to make a table. The x is the input, that's the number of tickets sold, and the y, or the f of x, is the output, that's the dependent variable, that's the amount of money collected. So if he doesn't sell any more tickets from here on out, he has made, well, let's calculate it. We do f of 0 equals 250 times 0 plus 20. 250 times 0 is 0, so we just get 20. If he doesn't sell any more tickets, he's already sold $20, so the output is 20. But if he sells one more ticket, let's find f of 1. Well, you plug in 1 in where x was, and you get 250 plus 20 is 2250. So if Manuel sells one ticket, he's collected $22.50. I'm going to continue plugging in values to the function and filling out this table. So we have 25 as the output when 2 is the input. When 3 is the input, we have $7.50 plus $20 is $27.50. And I'm going to end at 4, where when you plug in 4, you get out 30. Now, why did I end at 4? Well, he said he had 4 tickets left to sell, so he doesn't have 5 tickets to sell. So we have 4 tickets sold. He could have sold 0, 1, 2, 3, or 4 tickets. So the domain, the possible inputs are 0, 1, 2, 3, and 4. The range are these values on the right here, the possible amount of money he collected: 20, 22.50, 25, 27.50, and 30. Now the reason that these are separate numbers is because this is a discrete function. And it's discrete because he can't sell half a ticket. So you can't have 0.5 or 0.8 in the domain of the tickets. Likewise, because he can't sell part of a ticket, he can only possibly collect that much money, 20 or 22.50 or 25. He can't collect $21 because that would require him to sell part of a ticket. Remember, when it's a discrete function, the domain and range are going to be values like this. They might not be integer values. Notice we have 2250, but they will be separate values. If it was continuous, which a lot of times when time is the independent variable, it's a continuous function, then we would write a continuous domain and continuous range. All right, thank you for watching, and I hope you have a good day.